This video is going to cover Module 2, Homework 9 notes. Homework 8 talks about dividing polynomials by a monomial, which is one term. Now this time we're going to divide polynomials by a binomial, so that means two terms. And we're going to use synthetic division to do so. So before we talk about synthetic division, let's just talk about dividing two numbers in general. Let's go back to old school division, just to refresh our memory. I'm just going to make up some number. Let's divide something like 2 divided by 1025, 1025. So, in doing so, going back, old school, remember that we did 2 doesn't go into 1 because 1's smaller. So 2 goes into 10 5 times. Notice how it's written in this column. So then we did 5 times 2 is 10. Then we subtracted down. 10 minus 10 is 0. So then you brought down the next number, you brought down 2. Now the pattern starts over again. 2 goes into 2 one time. Then you did 1 times 2 is 2. Subtracted down, 2 minus 2 is 0. Bring down your next number, bring down the 5. So it's like the same pattern over and over again. 5 divided by 2 is 2. And then you do 2 times 2 is 4. Subtract 5 minus 4 is 1. There's nothing left to bring down. So this last number is your remainder. And I see a lot people write remainders as like this little r, like remainder 1. Or like the more correct version would be 512. And then your remainder, which is 1, over your divisor. So 1 over 2. So if you were to divide this into your calculator, 1025 divided by 2, that would give you that 512, and that 0.5 is your remainder, which is your 1/2. 1/2 is 0.5. So that is our old school long division. Now you can take this same concept and use it using your x's with your variables to divide polynomials, but we're going to use what's called synthetic division. So it's kind of like working backwards, and it's kind of like a little shortcut. So we're going to keep this in our back of our mind because it's the same idea of, you divide, you subtracted, you brought it up, you multiply down. Then you multiply down, you subtracted, multiply across, subtracted, multiply across, subtract, all that good stuff. So using that same concept, you can do the same thing with something like this. 2x cubed minus 5x squared minus x plus 3 divided by x plus 3. Now notice, compared to homework 8, going back, looks something like this. Notice we are dividing by one term. Now I'm dividing by two terms, x plus 3. Remember, terms are separated by addition and subtraction, so x is its own term, 3 is its own term, so dividing by two terms. So here's how we have to use this other division. I can't split it up like we did in homework 8. So instead of going through our long division like this problem, we have what's called synthetic division, which is kind of like our shortcut. So for the shortcut, we only look at the coefficients, we only look at the numbers, and then we go back and plug in the exponents at the end, or the variables at the end. So this is the same thing if you want to write it in fraction form as saying 2x cubed minus 5x squared minus x plus 3 divided by x plus 3. Now you need to start off by getting your divisor, which is on the outside. So to get that divisor, you're going to take your bottom, your denominator, your x plus 3, and you're going to set it equal to 0. Solving x, you're going to subtract 3 for both sides. Solving for x, you're going to get x equals -3. So that means this -3 is this number on the outside. This is going to be your divisor. Now, just like with our long division problem, everything was super organized in columns to represent your place values. Everything's going to be super organized in columns here. This time, instead of representing place values, it's going to represent our variable value. So, notice we have x cubed. That's our largest exponent, our largest variable. So this will be our x cubed column. This will be our x squared column. This will be our x to the first power column and x to the 0 power column. So notice it's in descending order, 3, 2, 1, 0, from greatest to least. All right, so instead of writing x cubed, I know we have 2x cubes. In my x squared column, we have -5. In my x power column, we have -1. And then in my variable column, my column with no variables would be +3. So 2, -5, -1, +3, all of our coefficients. So what synthetic division is just a pattern. It's going through the same pattern over and over again, just like in that previous long example problem we just did. So instead of doing long division, we're basically working backwards. So the last thing we did here was brought down a number. So here the first thing we're going to do is bring down this first number. Don't do anything, just bring it down. So we're going to bring down that 2. Now, over here, we divided and subtracted. We're going to do the opposite here. Here we're going to multiply and add. So we brought down this 2. We're going to multiply this 2 times our divisor, so 2 times -3, which would give us -6. Then we're going to add down -5 plus -6 would give us -11. Pattern starts over again. Multiply up. So -11 times -3 would give us +33. Adding down -1 plus 33 will give us 32. Going over again, starting over. 32 times -3 would give us -96. Adding down 3 plus -96 would give you -93. Now this is your answer. Notice you multiplied up by the divisor, then you added down. Multiplied up, add down. So we start at 2, multiplied up by 3, added down. Multiplied up by 3, added down. Multiplied up by -3, adding down, -3. So here's our answer. We have to just put our x's back in. So this last number is always our remainder. So going back, we have our x cubed. Look up here, we have x cubed and we divided or took away an x. So if we have 3 x's and we divided or took away 1 x, that means we're left with x squared. So this first thing, it's always going to go down 1 for synthetic division. So we have 2x squared. And then going in descending order from greatest to least. So 2x squared minus 11x to the first power, 1x, plus 32 with no x's, and then here's our remainder. So -93 divided by our divisor, which would be x plus 3. Just like here, we had a remainder of 1, dividing it by 2 to give us that 1/2 remainder. Here, we already divided this stuff by x plus 3. So then we have -93 as our remainder, divided by that x plus 3. So here would be our final answer, 2x squared minus 11x plus 32 minus 93 over x plus 3. All right, let's try one from scratch now, that you kind of know the deal. So find the quotient and the remainder using synthetic division for x cubed plus 5x squared plus 16x plus 46 divided by x plus 3. So notice it's in parentheses, so all of that is being divided by x plus 3. So I can rewrite it as x cubed plus 5x squared plus 16x plus 46 divided by x plus 3, if you like this look better. So the first thing we are going to do is find our divisor. So we're going to set our denominator equal to 0 and solve. So we have x plus 3 equals 0. We could subtract 3 from both sides. This would give us x equals -3 as our divisor. So we're going to do just like we did up here. I just write mine a little bit different. So my -3, I put it in a box this way. So that is our divisor. All right, so next let's set up our columns. So our greatest exponent is x cubed. So this means our first column is going to be x cubed. So it's going to be whatever your highest exponent is. And it's going to go in descending order, meaning from greatest to least. So x cubed, x squared, x to the first power, x to 0. So 3, 2, 1, 0 in descending order from greatest to least. So that's our columns, just to keep everything super organized, everything separate. So now let's put in our coefficients. Let's put in our numbers. So I have 1x cubed. We have positive 5x squared. We have positive 16x. And then we have positive 46. So here is our division problem. So our first step that we're going to do is we're going to bring down this positive 1. Bringing down positive 1. And then here goes our pattern. So we're going to multiply up by -3, add down, multiply up by -3, add down, multiply up by -3, add down. So let's do it. So 1 times negative 3 would give us negative 3. And then adding down 5 plus negative 3 would give us positive 2. So we're back in our starting point. Pattern starts over again. Multiply up by negative 3, adding down. So 2 times negative 3 would give us negative 6. Adding down 16 plus negative 6 would give us positive 10. Pattern starts over again. 10 times negative 3 would give us negative 30. Adding down 46 minus 30 would give us 16. And we're done. This is our last thing. So this last number is our remainder. So this is our answer. We just have to put our x's back in. So if we had x cubed and we divided or took away an x, so that means we're going to subtract our exponents. So x third power, so 3 minus 1, taking away 1x would give us x squared. So that means we're left over with x squared. So I have 1x squared plus 2x plus 10. So notice 2x is 1x, 0x, just like up here, 2, 1, 0. We went down one because I had x cubed divided by x, so I had 3x's, and we took away 1x. That means 2x was left over, x squared. And then our remainder would be plus 16 over our divisor, which is x plus 3. So that only the remainder is over x plus 3. Everything else got x plus 3 already divided into it. And this is our answer. On this problem on the homework, they kind of wanted you to write your answer in separate form. Quotient, which would be this first part, plus the remainder, which would be this part. So our quotient would be x squared plus 2x plus 10 and then our remainder would be 16 over x plus 3. And that's it. So recapping, let's write a couple little steps to kind of help us through this. So some steps to help us through this. Let me get a pen. All right, so our first step was we found our divisor. So what we did is we set the denominator equal to 0, and then we solved for x. So here we subtracted 3 for both sides. We got x equals negative 3. So this will give you your divisor. Sorry. So for step 1, set the denominator equal to 0 and then solve. This will give you the divisor. So the next thing that we did once we had our divisor was we set up our columns in descending order from greatest to least. So our second step was set up your columns in descending order. So descending order means going down. So 3, 2, 1, 0. Or 5, 4, 3, 2, 1, 0. Whatever your case may be, starting off at your highest exponent. Our highest exponent here was 3, so we start off with x cubed, and we went from greatest to least. So 3, 2, 1, 0. We went down. Our next step was we brought down this first number. So step 3, bring down that first number. And then once we brought down that number, our pattern can start. Our pattern says multiply up by the divisor, add down. Multiply up by the divisor, add down. So step 4. So multiply up by the divisor. Then we add it down. So here, multiply by negative 3, added down. Multiplied by negative 3, added down. Multiplied by negative 3, added down. And then we got all your answers, and then your last step is to put your variables back in. To write your final answer. And there's all your steps. If this helps you, if you're a step person, if you like to look at each step, because it's a very, just going through the steps, going through the pattern process. So if you need to pause it to finish writing that, go for it. If not, let's keep going. So find the quotient and remainder using synthetic division for x squared plus 3x minus 28 all over x plus 7. So just like our steps say, we need to set our denominator equal to 0 and then solve. So x plus 7 equals 0. Getting x by itself, we can subtract 7 from both sides. That way 7 minus 7 cancels out. We are left with x equals negative 7 as our divisor. So negative 7 goes into our little box. And then now we need to set up our columns. So if we have x squared as our highest exponent, so x the second power, x the first power, x the 0 power. So 2, 1, 0. So that tells us I have 1x squared, so positive 1 in the x squared column, plus 3x, so positive 3 in the x column, and then minus 28, which is our constant, meaning it has no x's. And then we need to bring down this first number, bringing down that one. And then here goes our pattern. Our pattern says multiply up by the divisor, add down. So 1 times negative 7 will give us negative 7. Adding down 3 plus negative 7 should give us negative 4. And if you need to do that in your calculator, go for it. 3 plus negative 7 will give us negative 4. And then negative 4 times negative 7 should give us positive 28. Negative 28 plus 28 will give us 0. So that means our remainder is 0. It goes in evenly. We'll use this a lot in college algebra. All right, so here's my answer, just putting my x's back in. Notice that our problem started off with x squared, and we divided or we took away an x. So if we have 2 x's and we divided or took away an x, we're left over with 1x. So I have 1x to the first power minus 4x to the 0 power with no x's, plus our remainder, which is 0 over x plus 7. Now notice I didn't box it in because this doesn't look great. I need to simplify it. That's just if that kind of helps you. Go for it. So plus 0 over x plus 7. 0 divided by x plus 7 is just 0. So I don't need to write that 0. We're left with 1x to the first power, which is just x, minus 4, and then with no x's. So I could just write x minus 4, and that is our final answer. All right, 2 more examples. So find the quotient and remainder using synthetic division for 4x cubed minus 23x squared plus 20x minus 22 all over x minus 5. So same thing, let's set this denominator equal to 0. So x minus 5 equals 0. We can add 5 to both sides. That would give us x equals positive 5 as our divisor. So positive 5 goes into our little box. So notice my highest exponent here is x cubed. So now my columns are going to start off with x cubed and then go all the way down to 0. So x cubed, x squared, x to the first power, and x to the 0 power. So 3, 2, 1, 0 x's in descending order going down. So now looking, I have positive 4x cubed. I have negative 23x squared. Don't forget that negative 23x squared. Positive 20x, and then minus 22, so negative 22. We're set up. I just need to bring down this first number, so bringing down that 4. So here goes our pattern. Remember, our pattern says multiply up by the divisor, add down. So 4 times 5 would give us positive 20. Adding down, negative 23 plus 20 would give us negative 3. Multiply up by your divisor, so always multiply by positive 5 every time. So 3 times positive, negative 3 times positive 5 is negative 15. Adding down, 20 plus negative 15 would give us positive 5. So now 5 times 5 would give us 25. Adding down, negative 22 plus 25 would give us positive 3. That's our last number, so this last number is our remainder. So that's our answer, just putting our x's back in. So I had x cubed, and I divided or took away one x. So I had 3 x's, and I divided or took away one of them. Subtracting your exponents, 3 minus 1 would give us 2, so we're left over with x squared. So I have 4x squared, and then now just going down. So 4x squared minus 3x the first power, plus 5 with no x's, and then our remainder, which is positive 3, over our divisor, which is x minus 5 from the original problem. And this is our final answer. So 4x squared minus 3x plus 5, and then plus 3 over x minus 5. We got this x squared because I had x cubed, and I divided by an x. That means subtract your exponents. So 3 minus 1 would give us x the second power. Then I went in descending order from here. So 2x's, 1x, 0x, and then our remainders on the bottom. Another way to think about your remainder being on the bottom is notice it's 2x, 1, 0. So this would be x to the negative 1 power. That negative power brings it to the bottom. So that's why that x minus 5 is on the bottom. So kind of cool to bring it all together. Notice only 3 is over x minus 5. Keep it separate, so leave it separate. Because everything else is already divided by x minus 5. All right, last problem. Find the quotient and remainder using synthetic division for negative 62x minus 36 plus 3 divided by x minus 8. Now notice this one looks different because I had to put everything in order, and I had to have something in each column of this. So let's put it in the right order. So starting off, x cubed is my highest exponent. So we know we're going to have x cubed. I don't have any x squared terms, so that means 0x squareds, and then minus 62x, and then minus 36, all over x minus 8. So you need to write that 0x squared because that will be a placeholder for that column. So in that column, you still have to have your x squared column. We just don't have an x squared term here, so that means 0x squareds. So, little note. So write in descending order. So starting off with our highest exponent, going down to no exponent. Greatest to least order with any placeholders. So now let's go on to find our divisor. So x minus 8 equals 0. If we were to add 8 to both sides, this would give us x equals positive 8 as our divisor. So positive 8 is our divisor. So now let's see, we have x cubed as our highest exponent. So this is our x cubed column, this is our x squared column, x the first power column, and then no x column. So 3, 2, 1, 0 in descending order from greatest to least. So now I have 1x cubed. I don't have any x squared, so we have to put that 0 for this column to show that there's no x squared terms, but I still have to have that column, so I can't just forget about it. I have negative 62x, and then minus 36 with no x's. So we're set up. Now we can bring down this positive 1. Here goes our pattern. Our pattern says multiply up, add down. So multiplying up by 8, adding down. So 1 times 8 is 8. Adding down, 0 plus 8 is 8. Again, multiply up, add down. So 8 times 8 would give us positive 64. Negative 62 plus 64 should give us positive 2. Positive 2. So then multiply up, add down. So 2 times 8 would give us positive 16. Adding down negative 36 plus 16 would give us negative 20. This is our last number, so this last number is always our remainder. So that's our answer, just putting our variables back in. Our highest exponent was x cubed, so that means if we divide or take away an x, we're going to be left over with x squared, starting off here with x squared. So we have 1x squared, positive 8x, so the first power, plus 2 with no x's. So if you need to write 1x, so 2x's, 1x, and 0x, and then minus 20 over our divisor because it's our remainder, so negative 20 over our x minus 8 from the original problem. So that's our answer, just simplifying it. 1x squared is the same thing as saying x squared, plus 8x, the first power, which is 8x, plus 2 with no x's, minus 20 over x minus 8. So remember, only negative 20 is over x minus 8. Everything else was already divided. So that's our final answer, x squared plus 8x plus 2 minus 20 over x minus 8. So this is all of Module 2 Homework 9, and thankfully it's all of our Test 1 notes packet. It feels so nice to have that whole big packet done. So you can go ahead and do all Test 1 homework, all Module 1, Module 2 homework, and quizzes. If you have any questions, please let me know. If not, thank you very much for watching, and you can now complete your Module 2 Homework 9 homework assignment. Thank you.